Hello everyone, I am Raghu. Welcome back to my channel Chemistry with RK. So let's continue the stoichiometry, the concept of oxidation numbers. So as I have discussed in the previous lecture, you can see the charges on all these elements, they are considered as stable charges. Okay, so later I termed those stable charges as oxidation numbers. So one of the very important points I would like to mention here is this is how we can able to understand the stable charges of different elements in the periodic table. Okay, so later the term stable charge I just taken it as oxidation number. So what is exactly oxidation number? Oxidation number is the stable charge of an element. So if you see what is the oxidation number for fluorine general case, all these charges, all these stable charges are the oxidation numbers in most of the probable cases. But when it comes to oxygen shows other than this -2 oxidation number, it shows so many oxidation numbers also. I'll explain, don't worry, like in which case the oxidation number is going to exhibit which oxidation number. Okay, so in the similar way, when it comes to nitrogen, general cases, nitrogen's oxidation number, we take it as -3. So I hope you know why -3, because it is present in 50A group, so it will have 5 valence electrons, so it requires 3 more valence electrons. So somehow if nitrogen can get those 3 electrons, then it is going to get -3 charge. Okay, and then other than this -3, nitrogen shows 0, +1, -3, and then +5, and then so many possibilities are there. Okay, so like once if we start explaining the oxidation numbers in a clear manner, so you can easily understand. Okay, and now firstly I just want to say, actually before losing electron by the sodium, it used to be a neutral atom. So this is generally a neutral atom, and now the sodium lost 1 electron and then it has become a positively charged cation. Okay, and then similarly if we move to fluorine, this was a neutral atom, and then by gaining 1 electron it becomes F-, which is an anion. So what we can understand, so generally all these elements before the gaining and losing, okay, so all these charges I have written only after considering their tendency to lose and tendency to gain the electrons. So before this gaining and losing tendencies, they were like neutral atoms. So for neutral atoms, the oxidation number we always take it as 0. Not only for sodium, not only for fluorine. So in all the cases for neutral atoms, the oxidation number is generally taken as 0. Suppose if I ask what is the oxidation number for sodium in this case, obviously the oxidation number will be 0. Similarly, what is the oxidation number of fluorine in this case? Obviously the oxidation number is 0 because they are neutral atoms. And now once after they lose, they gain, they get charges. Okay, so generally a neutral atom gets charged. So when we talk about charges, we know that positive and negative charges are there. So generally a neutral atom gets positive charged when it loses electron, positively charged. And then when do we expect a neutral atom to become positively charged? When they lose electrons. And then similarly a neutral atom gets negatively charged when they gain electrons. Yes. So if you can see here in the periodic table, these all cations. Okay, so lithium got +1 charge, beryllium with +2, and then aluminium with +3. So all these, after observing all this theory, then we can understand that. So actually, before gaining one electron, fluorine used to be neutral. After gaining, fluorine become F minus. Now it is no more a neutral atom. It is now a negatively charged species, which is generally called as anion. Similarly, before losing one electron, sodium or lithium used to be neutral atom. But after losing one electron, they become positively charged, generally called as cation. Hope you understood. So, what we can understand overall is a neutral atom becomes charged by losing or by gaining electrons. So anyway, we know that why and how these particular elements are charged with -1 for fluorine, -2 for oxygen, and then -3 for nitrogen, and so on. So these are general oxidation numbers. Okay, so these are the general oxidation numbers. When we are talking about a particular element again, so we may have more than one particular oxidation number also. So in general, we say oxidation numbers could be positive, negative, even fractional, or even zero. So 0 in which case, sir? 0 in the case of neutral atom. So what is the oxidation number of sodium here? 0. What is the oxidation number of fluorine here? It is 0. But whereas what is the oxidation number of sodium ion? This is now not a neutral atom. This is now sodium ion. So what is the oxidation number of sodium in this ion? Since it is a simple cation, the oxidation number will be is equals to its charge. Not only in this case, for all simple cations, the oxidation number of an element in that simple cation will be is equals to its charge. So it is simple. So what is the oxidation number of sodium in Na plus ion? It is +1. What is the oxidation number of fluorine in F minus? It is -1. So it is basically it is equals to its charge. Clear? No doubts, right? Yes. Please try to comment, or you can post, or you can just ask any kinds of question in the comment section. I'll be going through them, and then I'll try to answer your queries as soon as possible. Hope it is clear. There is no doubts, right? Yes. And now, just if we try to make out the things here, let us continue. Let us continue. So let me just give. So any neutral atom, okay, either by losing electrons or by gaining electrons, they get charged. Yes. And now when we think about charges, we have positive charge and then we have negative charge. Generally, the positively charged chemical species are called as cations, and then the negatively charged species are called as anions. And now, when do we expect the neutral atom to become cations, beta? So that is by losing electrons. And then when do we expect this neutral atom to get negative charge? That is by gaining electrons. Gaining electrons. Yes. Hope you understood. And now let us define. You please try to take the screenshot. Yeah. Next, generally in a molecule, the more electronegative element is going to show negative oxidation number, whereas the less electronegative element is going to show positive oxidation number. So for that, let me take just an example, that is hydrogen fluoride. So in this molecule, which element is more electronegative? So obviously fluorine. So fluorine is the ultimate element in the periodic table with more electronegativity. So this would obviously have the negative oxidation number. So if fluorine is taking negative oxidation number, hydrogen will take the positive oxidation number. Similarly, in NaCl, chlorine is more electronegative than sodium. So chlorine will take negative oxidation number, sodium will take positive oxidation number. Similarly, in ammonia molecule, among nitrogen and hydrogen, nitrogen has more electronegativity, so obviously that is going to show negative oxidation number, that is -3. Whereas hydrogen is less electronegative, then it will have positive oxidation number. Similarly, carbon dioxide, oxygen is more electronegative, then it is going to show negative oxidation number. Carbon is less electronegative, so it is going to show positive oxidation number. These charges I have taken from the periodic table. So these are the stable charges, so I have considered to this. Okay. Okay, let's continue. The next concept is oxidation numbers. Concept of oxidation numbers. Yes. So let us try to understand these oxidation numbers in a better way. So let me give you a few points. These points will help you a lot to find the oxidation number for any atom, whether it is an ion or a molecule. Yeah, okay. So then the first point will come out as the oxidation numbers for any neutral atom. Oxidation number for any neutral atom is taken as 0. Yes, this is fixed. So it could be any kind of neutral atom. So irrespective of metals, non-metals, metalloids, or irrespective of all these things, generally if you think about the oxidation number of any neutral atom especially, so then it is taken as 0. So we can just if you just see, I'll try to give one or two examples. So we will be taking any neutral atom. So it could be sodium, and its corresponding oxidation number, if we take, it is going to be 0. And then if we take even nitrogen, since it is neutral atom, its oxidation number is 0. And then fluorine, neutral atom, 0. Chlorine, neutral atom, 0. For all any such type of neutral atoms, the oxidation number is generally taken as 0. Okay, and then you please try to write down. Okay, please try to write down. And then next, if we move with the oxidation numbers for simple ions, the oxidation numbers with respect to simple ions. Okay, so I am writing here the oxidation numbers for simple ions. What do you mean by simple ions, sir? Simple ions will be included with simple cations. Okay, so simple cations will be coming into this, simple cations, and also simple anions. So what do you mean by this? Okay, actually what is the meaning of the simple ions? Actually simple ions are nothing but, you can see here so many ions in this periodic table. So which mean Li plus, it's a simple cation, F minus, it's a simple anion, and then similarly Na plus, simple cation, Cl minus, simple anion. So what we can understand from this simple ions concept, that is the ions. Okay, so let me just give you the definition here. Okay, ions which has only one type of element. Yes. So ions which have only one type of elements are called as simple ions. It could be a cation, it could be an anion, so we can call them as simple ions. So let me just give you here, that is simple ions, okay, and their oxidation numbers. So if you just think about Na plus, it is a simple cation because only one type of element is present in this. So its oxidation number is +1. Okay, and then next if we move with F minus, it is a simple anion because only one type of element is present. So its oxidation number is -1. Similarly, magnesium +2, it is a simple cation because only one type of element is there. So it's directly equals to its charge. Okay, so oxidation number for simple cation and for simple anion is its charge. It's very important. Please make a note of this. Okay, so it could be a cation or anion. If it is a simple cation or simple anion, then we can consider its charge as its oxidation number. So if we take O minus 2, like it is a simple anion, so its oxidation number is minus 2. Not only this, you can see so many simple cations and then simple anions here. So their oxidation numbers will be directly it's equals to its charge. Any doubts in that? Please try to take the screenshot. Okay, let's continue. So that is, next is the oxidation number for complex ions. What do you mean by complex ions, sir? Just now we have discussed simple ions. So complex ions will be quite opposite. Okay, so even in complex ions we'll have complex cations and complex anions. Yes, what are they, sir? Complex means, so for simple cations and simple anions we have discussed that ions in which only one type of element is present. When it comes to complex ions, so it is going to be ions, okay, ions in which more than one type of element, is present. So examples, yes, don't worry, I'll give you. So for these type of complex ions, the oxidation number for complex ions will be, okay, is taken as its charge. For the whole ion, I'm talking about for the whole ion, so it will be directly is equals to its charge. So what I need to tell you is, okay, so this is very important here. Suppose, let's say if I take some complex ions and their corresponding oxidation numbers. You can see here, I'm taking here that is SO4 minus 2. So it is a complex anion. So why it is complex anion? So we have sulfur, we have oxygen, so we have two types of elements present in that. So first of all, it is an ion because it has charge, and then it is complex anion particularly because it has more than one type of element. So for this entire complex anion, the oxidation number will be is equals to its charge again. And then we can take NH4 plus, it is a complex cation. Its oxidation number for the whole ion I'm talking about. I'm not worried about a particular element in that. I'll come to that in the next step. Okay, so for the whole ion, the oxidation number is taken as its charge. Suppose you can take carbonate ion, CO3 minus 2. What is its oxidation number? It is minus 2. And then even we can take H3O plus, hydronium ion. So what is its oxidation number? Plus 1. Clear? Hope you understood. Please try to take this screenshot. Okay, let's continue. That is, oxidation numbers could be, as I told you, 0, it could be negative, it could be positive, it could be fractional as well. Okay. So we will be getting all these examples, don't worry, plenty of examples I'll try to give you. So first of all, you have to be confident that oxidation numbers could be positive, negative, 0, even fractional forms also possible, okay. And then next, if we move to the oxidation number for any neutral molecule, oxidation number for any neutral molecule is taken as, again, 0. Yes. What does it mean? So if you take any neutral molecule such as, so let me give you neutral molecules. It could be, so many neutral molecules. Here H2O is a neutral molecule, NH3 is a neutral molecule, CH4 is a neutral molecule, and then SO2 is a neutral molecule. Like if we are particularly, so for this entire neutral molecule, the oxidation number is taken as 0. So please don't confuse. This is for entire molecule. Particularly if we are going to calculate the oxidation number of a particular element in a neutral molecule, then it is not going to be 0. Clear? So generally if we talk about a neutral molecule, then its oxidation number is taken as 0. So let me just change here itself, that is oxidation number. Yes, let me just give you this. The sum of oxidation numbers of all the elements in a neutral molecule. Yes, the sum of oxidation numbers of all the elements in a neutral molecule is equals to 0. Yes, what does it mean, sir? Suppose, let's say, just now I have taken H2O. Okay, so if we consider, suppose, let's say, for time being I am taking the oxidation number of hydrogen is X and then oxygen is Y here. So what does this point mean? The sum of oxidation numbers of all the elements in the neutral molecule will be is equals to 0. So what we can write down is, since for each hydrogen I have assumed it as X, 2 hydrogens are there, so that is 2 into X plus Y is equals to 0. This is what I mean to say. Hope you understood. Suppose let me take CO, that is carbon monoxide, simple molecule. In this case, suppose let's say I am taking the oxidation number of carbon as X and then oxygen as Y. So what this point mean is, sum of the oxidation number of all the elements in a neutral molecule is equals to 0, which means that X plus Y is equals to 0. Clear? Similarly, let me take NH3. Yes, so sum of the oxidation number. Suppose let's say I am here taking it as oxidation number for nitrogen is A, oxidation number of hydrogen is B, and then in this case we can write down A plus 3B is equals to 0. Hope it is clear. So we will go with so many examples, don't worry, just you try to understand. Okay, so whenever we have such type of neutral molecule, so we have to calculate the oxidation number like this. Okay, so yes, even we can have, suppose let me take H2CO3, carbonic acid. Okay, suppose let's say here I am considering the oxidation number of hydrogen is X, oxidation number of carbon is Y, oxidation number of oxygen is Z, and then what we can write down here, 2X plus Y plus 3Z is equals to 0. So whatever we can we can do any operation here, but the sum of oxidation number of all the elements must be 0 in a is equals to 0 in a neutral molecule. Thank you. And then next, okay, so let me just go with the next one, that is the oxidation number of an element, in homonuclear molecules. Yes. Okay, what is that? The oxidation number of an element in a homonuclear molecules is always taken as 0. Okay, so I've been giving you so many points here. So try to understand them. Don't try no need to by heart them, no need to remember them. Try to understand. Okay. So oxidation number of an element in a homonuclear molecule. What do you mean by homonuclear molecule? A molecule has only one type of element. Suppose let's say if you take O2. Yes, this is a homonuclear because two atoms are there, two elements are there. Both of them are oxygens. So in this case, the oxidation number of oxygen, that is, okay, so since it is a homonuclear molecule, the oxidation number of oxygen is taken as 0. Suppose let's say we have ozone. Yes, this is still a homonuclear molecule. The oxidation number of oxygen is equals to 0. Okay, let me take P4, we generally call this as white phosphorus. Since this is a homonuclear molecule, yes, we have 4 elements, 4 atoms are present in this molecule, but all the atoms are similar type. So the type of molecules called as homonuclear molecules. For all such homonuclear molecule, the oxidation number of phosphorus in this is 0. Without any hesitation, we can take 0 for the elements in a homonuclear molecules. Clear? Even we can take, let me just take S8 molecule. The oxidation number of sulfur is also can be taken as 0. Clear to everyone? So please try to take the screenshot here. Okay, next the oxidation number of metals in alloys is generally taken as 0. So what are alloys? The mixture of two or more than two metals are called as alloys. So let me give you an example, that is brass. So if we talk about brass, then it is an alloy of copper and zinc. Whereas the other example we can take bronze. So it is an alloy of copper and tin. So if we talk about the oxidation numbers of these elements in these alloys, we can take the oxidation number is equals to 0. So it's not only in these two examples, we can take any of the alloy. In those alloys, the oxidation numbers of those metals is generally taken as 0. Next, the oxidation number of metals in amalgams is taken as 0. And now, what are amalgams? Actually, amalgams are the class of alloys, but whereas one of the metal is taken as mercury. If in an alloy, if one of the metal is mercury, then we can call that alloy as amalgam. So, in case of amalgams, the oxidation number of metals is taken as 0. So, suppose let's say we can take the example of zinc amalgam, that is zinc plus mercury will be there. So, in this particular zinc amalgam, we call this as zinc amalgam. This compound is called as zinc amalgam. In zinc amalgam, we have zinc and mercury. The oxidation number of zinc is taken as 0. Similarly, the oxidation number of mercury is also taken as 0. Next, the oxidation number of generally first A group metals. So it could be lithium, sodium, potassium, rubidium, cesium. So we generally take the oxidation number of first A group metals, they are called as alkali metals, is taken as +1. So I already shown you here, since they are present in first A group and they are metals, so they loses one electron. So that's why their oxidation number is taken as +1. Similarly, the second A group metals, they are called as alkaline earth metals. Since they lose 2 electrons, their oxidation number is taken as +2. Similarly, when it comes to 7th A group elements, they are called as halogens. Since they are non-metals and they have 7 valence electrons with them and they want 1 electron, so by gaining that 1 electron, they are going to get -1 charge. So that's why their oxidation number is -1. Next, when we move to hydrogen, hydrogen can show two possible oxidation numbers here, that is +1 and -1. So hydrogen can show +1 when it combines with non-metals. So I already gave you that example. Again I am giving you, that is hydrogen fluoride. So since hydrogen is combined with a non-metal, so fluorine has only opportunity to have -1 charge. So in that case, hydrogen would obviously take +1 charge. Similarly, we can go with HBr. Since bromine is a non-metal and it has only one choice, that is -1, so it will take +1 charge. So when generally hydrogen combines with non-metals, then it will show +1. When it comes to -1, when hydrogen combines with metals, then it is going to show -1. So let us take one example, that is sodium hydride. So since sodium has only choice, that is +1, hydrogen would have -1 charge. Similarly, we can go with the second A group metal, that is MgH2, magnesium hydride. Magnesium has only choice, that is +2, so hydrogen will take -1. And then similarly we can take AlH3, that is aluminium hydride. Since aluminium has only choice, that is +3, then hydrogen will take -1. Next, the oxidation number of metals in metal carbonyls is generally taken as 0. And now what are metal carbonyls? So generally metal carbonyls are the class of complex compounds. Okay, so you might have seen this type of compounds, somewhere, yes. So this type of compounds are called as complex compounds. So especially in the complex compounds, you will have a coordination sphere. Within that coordination sphere, we will have a transition metal, mostly a transition metal combined with some number of groups called as ligands. So they are called as ligands. If the ligands are all carbon monoxide molecules, then we can call them as carbonyl ligands. So such type of complexes are called as metal carbonyls, where our coordination sphere is going to have only a metal with carbonyl ligands. Okay, so I'm not going to go into the deep of this. Okay, so just you try to understand whenever, like if we see this type of complexes, they are generally called as complex compounds, in which the oxidation number of the metal is generally taken as 0, since these carbonyl ligands are neutral, so they are not going to contribute any oxidation number in the calculation of metal oxidation number. Clear? So generally, let me just give you these ligands are of different types: positive ligands, and then negative ligands, and then we even have neutral ligands. And now I'll just quickly I'll try to give you some positive ligands, where we have NO2 plus, and then we have NH2, NH3 plus. Okay, so etc. We have so many, but as far as our concept is concerned, so let me be particular with few. Okay, so we have a separate chapter called as complex compounds in the second year intermediate. Okay, so we will discuss the maximum number of possible examples in case of the complex compounds. But as far as our oxidation numbers is concerned, so I'm going to give you the relevant information. So these particular ions generally considered as positive ligands. Now, what do you mean by positive ligands, sir? They are going to contribute plus 1 charge to the oxidation number. Similarly, if we take the negative ligands, we take Cn minus, cyanide ion, we take OH minus, what is that, hydroxide ion, and then etc. We have so many: Cl minus, Br minus, I minus. They are all neutral ligands, negative ligands. They all contribute -1 charge to the oxidation number. When it comes to neutral, we have H2O, we have NH3, so we have CO. Yeah, these are all comes under neutral ligands. So whenever these molecules are present as a ligands, they are going to contribute 0 oxidation number to the metal. So I hope you understood. Since in metal carbonyls, we will have only the metal attached to the carbonyl group, so the oxidation number of metal in the metal carbonyls, we can directly take it as 0. Hope you understood. And next, when we think about the oxidation number for an element, we can have two possibilities, that is the minimum oxidation number or general oxidation number we say, and the other one is maximum oxidation number. So what does it mean? So if we think about the nitrogen's the minimum oxidation number or the general oxidation number is -3, whereas its maximum oxidation number is +5 because its group number is 58. So what does it mean? For nitrogen, it can have the oxidation number from -3 to +5. So in between these minimum oxidation number and the maximum oxidation number, the other numbers are also possible. So it can have +1, it can have +2, it can have even fractions in the hydrozoic acid, compound hydrozoic acid, and then +5 in nitric acid. So these are the possibilities. When we think about chlorine, so the minimum oxidation number is -1, whereas the maximum oxidation number is +7. So why? Because it is present in 7th A group. It has a 7 valence electron, so it requires 1. That's why it is -1. And now its group number is 7th. The maximum possible oxidation number for chlorine is +7. So what does it mean? In between these -1 and +7, the remaining numbers are also possible. So likewise, every element can have its minimum oxidation number and maximum oxidation number. Anyway, the maximum oxidation number is going to be its group number. So we can say that the oxidation number for any element never goes beyond its group number. So now let us learn how to calculate the oxidation numbers for an element when a compound is given. Okay, so let us take a molecule H2SO4 sulfuric acid. So you may get a doubt, sir, how do we know to which particular element we need to calculate the oxidation number? So there are two possibilities. They may mention to which particular element we need to calculate the oxidation number. If they don't mention, then we can directly calculate the oxidation number for the central element or the central atom. Sir, how do we identify the central atom? In that particular molecule, the element which shows more number of maximum oxidation numbers, so that particular element is going to be our central atom. So in this case, sulfur is our central atom. And now how to calculate, sir? So the element to which we need to calculate the oxidation number need to be taken as X. And for the remaining elements, we must know the oxidation numbers. How do we get to know, sir? So if you just go through my previous in this same video, if you just go to the starting, and then I gave so many rules. So for hydrogen generally we take +1, and for oxygen generally we take -2. So all these rules we must understand. By using those rules, we can calculate the oxidation numbers for any elements in a given particular molecule. And now we need to calculate oxidation number for the sulfur, so that we need to know the oxidation numbers for the hydrogen and oxygen. We know anyway, that is for each hydrogen it is +1. And how many such hydrogens are there? 2 hydrogens. So 2 into +1, and then there is 1 sulfur. For each sulfur we need to take it as X. And we have 4 oxygens. Generally we take oxygens, oxidation number is -2. And we know, we discussed that the sum of oxidation numbers of all the elements in a molecule is taken as 0. So all these oxidation numbers is taken as 0. That's why we take generally equal to 0. This is not possible for the ions. Okay, let me come to that soon. First of all, this is +2 plus X minus 8 is equal to 0, X equal to +6. So we are going to get X for sulfur, the oxidation number is going to come out as +6, which is its maximum oxidation number, because sulfur is present in 60A group. So its maximum oxidation number is +6. Okay, so let me take another example here, that is H2CO3 carbonic acid. And now I have underlined the element to which we need to calculate the oxidation number. So let us calculate this. We have 2 hydrogens, for each hydrogen +1, and then we have 1 carbon, and then we have 3 oxygens. For each oxygen -2 is equal to 0, and then 2 plus X minus 6 equal to 0, X minus 4 is equals to 0, and then we are going to get the oxidation number of carbon is +4. Hope you understood. Likewise, we need to calculate the oxidation numbers. We can able to calculate the oxidation number for any element in a given molecule. So let me just give you, that is sulfurous acid, H2SO3. H2SO3 is sulfurous acid. And now how to do this, sir? So we can take the same, that is 2 into +1 plus 1 into X. But how many oxygens we have? 3 oxygens. So we can just replace this with 3 into -2. So that we are going to get, this is -6. So that we are going to get X minus 4. So that we are going to get X equal to +4. So for sulfur, +6 possible, +4 possible, +2 possible. For every element, the common oxidation number possible is 0, and we even can have -2. So these are the possible oxidation numbers for sulfur. Okay, and now let me give another compound, that is potassium permanganate, KMnO4. And now we need to calculate the oxidation number for manganese, suppose. And then we need to know the oxidation number for the remaining elements we know very well. Potassium present in first group, so +1 charge. How many potassiums? 1. And then for 1, +1. And then manganese we need to take it as X. And 4 oxygens we have, that is each oxygen need to be taken as -2. So we are going to get that is 1 plus X minus 8 equal to 0. X minus 7 is equal to 0. X is going to be +7. Hope it is clear. So this is how we are going to calculate the oxidation numbers. Hope you understood. So this is very easy if you know the oxidation numbers for the remaining elements. Okay. And now let me give some other example here. Some other example. Okay. Hope you have. Hope you are writing that. Okay. And then next, let me give you that is Na2SO4. Na2SO4. That is sodium sulfate. The oxidation number of sulfur we need to calculate. Sodium is present in first A group, so each sodium will be taken as +1. 1 sulfur X. 4 into each oxygen -2. So 2 plus X minus 8 is equal to 0. X is going to come out as +6. Hope you understood. Hope you understood. Okay. And now next, let me take some other example. K2Cr2O7 potassium dichromate. We need to calculate the oxidation number of chromium. Suppose potassium first A group +1. 2 chromiums are there. For each chromium X. And then 7 into for each oxygen -2. And now this is 2 plus 2x minus 14 equal to 0. 2x equal to 12. X is going to come out as +6. Hope you understood. This is how we are going to calculate the oxidation numbers. Now I am going to give few molecules and I am going to underline for which element we need to calculate. Okay. So just you try to write down these molecules and calculate the oxidation numbers and then try to give your answers in the form of comments. I'll be observing, I'll be replying to all your comments. Okay. So just let me give you few compounds and then we need to calculate the oxidation number for sulfur and then for sulfur in this and then even HNO3 in this. And then we can take HNO2 in this and then you can calculate the oxidation number of phosphorus and we can calculate the oxidation number for sulfur in H2S and then you try to calculate the oxidation number for nitrogen and then for OF2 in oxygen and then O2F2 we need to calculate the oxidation number. You try to take that is HCN, that is carbon's oxidation number, and then you try to take methane, carbon's oxidation number, calculate that, and then K2MnO4. K2MnO4 is potassium manganate, and then you need to find out the oxidation number for manganese. Okay, you please try to write down these compounds. You will find so many in your books, so you can just go with any of the molecule. You try to calculate the oxidation number. Yes, the same rules we need to apply. We are going to get answers for each and every question. Okay. Now let us calculate the oxidation number for the elements in ions. So let me take sulfate ion, which is SO4 -2, and we need to calculate the oxidation number for sulfur. Let us take. And now same procedure, 1 sulfur X and each oxygen it is -2, which is going to be equal to its overall charge. So that is the only difference between the normal neutral molecule and ion. So generally in molecules we take equal to 0, in ions we take its charge, that's it. So here also we are going to get it is +6 if you calculate. And now if you take SO3 -2 sulfur, that is 1 into X plus 3 into -2 is equal to -2, and then X is going to come out as +4. Similarly you take nitrate ion, that is NO3 minus. If you calculate the oxidation number for nitrogen, that is 1 into X plus 3 into -2 is equal to -1. So this is -1, and then X is going to come out as +5. Similarly, if you take Cr2O7 minus 2, chromium's oxidation number 2 into X plus 7 into minus 2 is equal to minus 2 overall charge. So X is going to come out as plus 6. So this is how we are going to calculate the oxidation numbers for ions. Hope it is clear. Suppose let's say, let me give you the simple cation, that is Mn plus 2. So if I ask you the oxidation number of manganese, since it is a simple cation, we know that its direct charge is its oxidation number. Suppose let's say I gave you F minus, what is the oxidation number of fluorine in that? Obviously it is going to be its charge, minus 1. Suppose if we have N minus 3, what is the oxidation number of nitrogen? Minus 3, clear? So for this category I am going to give few examples, you try to do and then if any queries are there, so please try to contact to me. And now let me give you, that is carbonate ion, CO3 minus 2. Similarly MnO4 minus, manganate ion, and then this is permanganate, and then MnO4 minus 2, this manganate ion, and then we can also take ClO4 minus, perchlorate ion, chlorate, we have to calculate the oxidation number for chlorine. Similarly ClO3 minus, this is chlorate ion, and then let us take so that is ClO2 minus, this is chlorite ion, and then ClO minus, hypochlorite ion. Calculate the oxidation numbers for all these elements. Okay. So it's not only these particular ions, we can also take so many. Okay, so please you just try to do different types of questions. So I am giving you already several examples in the lecture itself, so try to take that advantage. Okay, so H3O plus, I want the oxidation number of oxygen, and then we have, this is carbocation, methyl carbocation. We generally call this as methyl carbocation. We will be talking about this in particular in the organic chemistry. And then we have methyl carbene ion, CH3 minus. Okay, so try to find out the oxidation numbers for all these underlined elements. Okay, you try to take them, write down. You just try to pause that and then write down those examples. Okay, and now let me give you some different types of examples now. Okay, these are the common examples which you can able to do. And now if we take hydrogen peroxide, if we try to calculate the oxidation number of oxygen here, how much we are going to get? 2 into plus 1 plus 2 into x is equal to 0. Then 2x equal to minus 2, x equal to minus 1. Now the oxidation number of oxygen we got as minus 1, which indicates that H2O2 has a peroxy bond or peroxy linkage. I hope you understood. So generally we know that oxygen, if it gets a minus 1 charge or minus 1 oxidation number, then it is called as peroxy bond will be there in that compound. So this compound is hydrogen peroxide. And if we have potassium superoxide, if we try to calculate the oxidation number for oxygen, what is that we are going to get? 1 into plus 1, that is for potassium plus 1. And then 2 into x equal to 0, then x is going to come out as minus half. For oxygen's oxidation number, we got it as minus half, which indicates it is a superoxide. Hope you understood. Suppose let's say we have BaO2, and now we need to calculate the oxidation number of oxygen. How much we are going to get? 1 barium we have plus 2, and then 2 into x equal to 0, x is going to come out as minus 1. So this is now barium peroxide. Okay, since the oxidation number of oxygen we got as minus 1, so it is called as barium peroxide. Clear? And now we can take few more examples. Just let me take few more examples. Suppose let's say we have H2SO5. These are all very important examples. Yes. And now if we want the sulfur's oxidation number, if we calculate how much we are going to get, that is 1 into x plus 5 into minus 2 is equal to 0, x 2 plus x minus 10 equal to 0, x is plus 8. The value of x we are going to get as plus 8. For sulfur, what is the maximum possible oxidation number? It is plus 6 only. But how come plus 8 is possible? Obviously, this is wrong. The possible oxidation number for sulfur is plus 6 maximum. So, but here we are getting plus 8. So, obviously, this is wrong. And now, sir, how do we get to know the oxidation number we are going to get is whether it is correct or not? So for that, better if you know the group numbers. That will help you a lot. Not only in this particular concept, even to understand the chemistry. So it will help you a lot. Learning the group numbers and period numbers will give you additional strength to understand the subject. Okay, and now, sir, then what is the correct or possible oxidation number for sulfur? So in such case, if for an element, if the oxidation number is going to beyond its group number, so we can directly take its maximum oxidation number is its group number, is its oxidation number for that particular molecule. And now what does it mean, sir? Here we have got plus 8, but that is wrong because the group number of sulfur is 68. The maximum oxidation number is plus 6. So in this case, we can go with x equal to plus 6. This is going to be the correct answer. But let me tell you, how come this plus 6 is going to come for this H2SO5? So just one thing I would like to say here is, whenever we are getting oxidation number beyond its group number, then we can expect peroxy bonds in between in that particular compound. Now, what does it mean, sir? Suppose if you see H2SO5 structure, sulfur is the central atom. Its group number is 68. The maximum number of bonds it can form are 6. Among them, we can have 2 double bond oxygens. And now the remaining 2, 4, 5, 6 are completed now. Then we can have OOH, and then there is one more oxygen and hydrogen bond. If you see the structure here, oxygen single bond is called as peroxy bond. For peroxy bonds, we know oxygen's oxidation number need to be taken as -1. So here in these two cases, -1 and -1 is taken. For the rest of the oxygens, we need to generally take it as -2. And now if we try to calculate the oxidation number, we are going to get plus 6. So for two hydrogens, it is 2 into plus 1, 1 into X for sulfur. Among these 5 oxygens, 3 oxygens are generally taken as normal oxide, that is 3 into -2. And then 2 oxygens, we need to take it as peroxy oxygens, so -1. And now in this case, X is going to get as plus 6. Hope you understood. So better if you know the group number so that you can easily identify. Yes, there are peroxy bonds possible in some compound. So there are so many questions asked in previous IIT, JEE and NEET exams also. That is, which of the following compounds will have peroxy bonds? So we can able to calculate its oxidation number, and if the oxidation number is it's beyond its group number, then that particular compound can have peroxy bonds. So likewise, we can able to tackle the IIT JEE questions. So let me just give another example if you are okay with this, please. And now let me just give you another example, same within the sulfur family, that is H2S2O8. Okay, actually just forgot to give you the name. H2SO5. H2SO5 is called as Carros acid. The compound name is Carros acid. The other name is also there, that is peroxy monosulfuric acid. Yes, they may ask question in this way. Calculate what is the oxidation number of sulfur in Carros acid. What is the oxidation number of sulfur in peroxy monosulfuric acid? So then it is going to be H2SO5, then it is going to be plus 6. Okay, and then next let me take other example, that is H2S2O8. And now we need to calculate the oxidation number of sulfur again. So what is the compound name, sir? Compound name is going to be Marshall's acid. Marshall's acid, and then the other name is also possible, that is peroxy disulfuric acid. Peroxy disulfuric acid. And now if we calculate the normal oxidation number, how much we are going to get, sir? 2 into plus 1 plus 2 into x plus 8 into minus 2 is equal to 0. Then we are going to get the oxidation number as plus 7, which is not possible again. In such case, directly we can go with the number plus 6. This is, right, this is 100% true. But if you want to know how come this plus 6 is going to come, so then we need to draw the diagram to understand that. So sulfurs, we have 2 sulfurs, beta. I told you to take 2 double bonds and then 2 single bonds are left. And now there is 1 OH this side and then 2 oxygens are present in between the sulfur, so that it is going to be considered as a peroxy bond again. Peroxy bond, so these 2 oxygens are peroxy oxygens, so minus 1 for those 2 oxygens, for rest of the 6 oxygens minus 2, so you are going to get X value as plus 6. So this is how we are going to confirm whether the compound has peroxy bonds or not. There are so many questions possible from this diagram itself. Okay, so we are going to talk about this diagram in detail in the 16th group elements in sulfur oxy acids. Okay, yes, and now let me give you one more compound of this type, so where the oxidation number goes beyond the group number, which is not possible. Okay, and now let me give you, that is chromium pentoxide. Chromium pentoxide, chromium's oxidation number if we want. Generally if we calculate, we are going to get plus 10, but the group number of chromium is 6b. So the group number is 6b, the oxidation number can't go from plus 6. Okay, beyond plus 6 it is not possible, but in this case it is coming out as plus 10, which is not at all possible. In such case, expect about the peroxy bonds. Peroxy bonds, obviously we can expect the peroxy bonds. Actually this compound has a different type of compound, where the compound looks like butterfly. This chromium have a double bond O, and now you see how many peroxy oxygens are there. 4 peroxy oxygens are there, so we need to take minus 1 for those 4 oxygens. Normal, another oxygen will be taken as minus 2, so then we are going to get the oxidation number is plus 6. So this is the correct oxidation number. Let me give you one more, that is H3PO5, which is called as peroxy monophosphoric acid. And now generally if you calculate the oxidation number with general method, that is 1 into x plus 3 into plus 1. Okay, so let me write down this clearly, that is 3 into plus 1 plus 1 into x plus 5 into minus 2 is equal to 0. Then how much we are going to get? X is equals to plus 8. Okay, we are going to get plus 8, which is 100% not possible for the phosphorus. For phosphorus, the maximum oxidation number possible is plus 5. So directly you can go for oxidation number plus 5. But how come this is possible? Through the structure we can understand. Okay, if you just observe, this is the structure we are going to get. H3 PO5, so this is OH, yes. And now what we can understand here, there are 2 peroxy oxygens need to be taken as minus 1, for the rest of the 3 oxygens minus 2, for the rest of the 3 hydrogens it is plus 1. Finally you are going to get the phosphorus oxidation number is plus 5. So this is how we are going to understand the oxidation number calculation. Okay, and then next let me give you few more examples of different types. Okay, so please you try to write down the compound name. H3PO5 is peroxy monophosphoric acid. And then next if we have a compound like let me give you, that is Br3O8, where we need to find out the oxidation number of bromine. So if I just ask you to find out the oxidation number of bromine, we are going to get, that is X is going to be, so let me just calculate in a simple way, that is 3 into X plus 8 into minus 2 equal to 0. that x is going to be plus 16 by 3. This is the average oxidation number we say. Okay, average oxidation number. But in particular, if we want the oxidation number for 3 bromines particularly separately, then we need to go with the diagram. So bromine is here, and then we have Br, and then Br, and then we have bromine, and then we have bromine, and then double bond O, we have again bromine. Yeah, this is the possible structure of Br3O8. Okay, and now here very important point to understand, that is to find out the oxidation number for each bromine individually, we need to consider their bonds here. So how many bonds are there around bromine? Yes, around bromine totally we have 7 bonds, but in between 2 bromines there is a common bond. So in between 2 similar elements, if we have any bond, so that is not going to contribute anything into the oxidation number. So for this bromine, what is the possible oxidation number? So oxidation number key, only these 6 bonds are going to contribute, so that is plus 6, and now in this, these 4 bonds are going to contribute, so plus 4. Then this for this bromine, again these 6 bonds are going to contribute. The bond present between 2 similar atoms need not to be considered while calculating the oxidation number. So this is going to be plus 6, plus 4 and plus 6. Even if we take the average now, it is going to come out as the same, plus 16 by 3. Individually for each bromine, it is going to be plus 6, plus 4 and plus 6. Any doubts in that? Yes, thank you. And then next we have C3O2, which is called as carbon suboxide, where we need to calculate the oxidation number of carbon. So if we calculate generally, that is, it is going to come out as minus 2 is equal to 0. Then it is x is going to be plus 4 by 3. And now the point is individual. So this is average oxidation number. This is the average oxidation number. Okay. Even if we calculate the average oxidation number in this case, also you are going to get the plus 16 by 3. So this is average oxidation number. This is individual's bromine's oxidation number. They may ask, in what is oxidation number of central bromine in Br3O8? It is going to be plus 4. Okay. And then what is the oxidation number of terminal bromines in Br3O8? It is plus 6. And then C3O2, the structure is going to come out as, this is the structure. How to draw the structure, sir? Keeping the group numbers in mind, that's it. Carbon group number is 4th, so maximum bonds are 4. So those 4 bonds can be formed in any of the possible ways. So this is what is the oxidation number of this carbon here? The oxidation number contribution will be only from these 2 bonds. Since these 2 bonds are present in between the similar atoms, so it is going to be plus 2. And now for the central carbon, it is going to be 0, because both sides it has same bonds between same atoms. And now the last one, the terminal carbon also have plus 2. And now if you take the average oxidation number is going to be plus 4 by 3. It is going to be similar. Okay. So clear. And now, thank you. And then next, let me just go to some other molecule. Okay. And then next, let me take bleaching powder. What is bleaching powder formula? So calcium hypochlorite, that is CaOCl2, which is going to be the calcium hypochlorite, which is our bleaching powder. And now actually this particular compound, if it gets dissociated, then we are going to get 3 particular ions, that is Ca plus 2, and then Cl minus, and then we are going to get OCl minus. So which is nothing but chloride ion we are going to get, hypochlorite ion we are going to get. And now individually the chlorine's oxidation number. So in this particular compound, we are going to have 2 different oxidation numbers for the same chlorine. That is, in this it is going to be minus 1, in this chlorine it is again we need to calculate. 1 oxygen we have, for each oxygen minus 2, and then 1 chlorine we have, we need to find out, and then is equals to minus 1. So x is going to come out as plus 1. So what is the oxidation number of chlorine in bleaching powder? So we have 2 particular oxidation numbers possible, that is plus 1 and then minus 1. Similarly, if we take some mixed oxides like Fe3O4, this is a mixed oxide. which is made up of two different oxides, FeO and Fe2O3. And even in this particular Fe3O4 also, we are going to get two different oxidation numbers for two different iron atoms. So that is, here it is +2 and here it is going to be +3. Okay, if you take the average oxidation number, generally if you calculate how much we are going to get, that is going to be that is 3 into x plus 4 into -2 is equal to 0. That is going to be 8 by 3. That is going to be plus 8 by 3. And now, even by calculating this, we need to get the same answer. That is, it is +2 here, and then for each iron it is +3. For 2 irons it is +6 by 3. That is going to be +8 by 3. Okay, so this is about the oxidation numbers. Okay, so we will be coming across so many different types of compounds. Okay, so all I just want from you is your support. I am going to give many more examples. I am going to take the next class is completely based upon the oxidation numbers. Okay, my next class is going to be completely on oxidation number calculations. So just please follow the channel regularly and then don't miss any updates. For that, all you need to do is please subscribe and then please don't forget to click on the bell icon so that you get the regular updates. Thank you so much. See you.